Hi everybody, my name is Brandon Graisley. I'm a high school computer science teacher. This is part 5 of our series using libGDX to make a space shooter game, and so far we have lasers and ships and a scrolling parallax background. And today we're going to talk about how to know when lasers are hitting the ships. And so right now you can see they sort of just pass or topper right through each of the ships. The shields are unaffected, and so we're going to work on that today. And this is a surprisingly complex challenge. So there's a lot to get as far as you might hope today because there's a lot to learn. So let's start by talking about the lasers here. This is one way that lasers can impact into a ship, right? We have this little image that hits this little image and everything seems fine. The problem comes when we have a laser that hits more like this. It's hitting the image of this ship, but it's not hitting the ship itself. And so there's a challenge of deciding when does the laser really strike the ship. Does it hit the ship as soon as the images overlap, or does it have to overlap at a certain distance? It's pretty complicated. So for today, all we're going to do is the simple idea that if this image hits the ship image anywhere, then there's going to be an intersection. We're going to do a little bit more than that with the enemy ship. But this unfortunately is not a great solution for a ship like this because it's basically not a rectangle. Okay, well let's take a look at what this looks like in code. So before we get to that portion of the lesson, let's start cleaning up our code in the game screen class a little bit. We have a few things that we can improve. So here's my render method. We have a batch.begin. We update the player ship and the enemy ship, make the background, draw the enemy, draw the player, and then a whole bunch of laser stuff. And then we have the end here. Now let me back up again to that render background call. That call right there is that we have a fairly complicated thing that has to happen, and so we've made a private method called render background that will look after it. And I would like to do the same thing for the lasers. So render lasers, and I'll give it delta time as well. I'm not sure if we need that. I'm going to take all of this code here, all of the laser stuff. I'm going to cut it out, and I'm going to make a new private void render lasers method that takes that float delta time. And inside that method I'm going to paste all of that code. Now it doesn't clutter up my main render method. Now I'm going to take a quick look at it and see, did I use that delta time variable anywhere here? I did. It's used here to when the lasers are moving to decide how far they move. So we do need that as a parameter. And now I've been able to simplify the look of my render method without any real cost, just bumping down here to run that code. Now this is a lot easier to read. We start the batch, we update the player and enemy ships, render the background, draw the two ships, that could maybe be a single method, render the lasers, and then you can imagine here we might want one like this, render explosions. We're not going to do that today, but I'll make a private method for it for later. And that's where the code will go, and then this render method stays nice and easy to read. So let's figure out how do we detect collisions between the lasers and the ships, and when should that happen. So I notice here we have player ship and enemy ship updates, and a little bit lower down we will render the lasers. Let's just take a look at that render lasers method again. The lasers are kind of created all in here, and they're moved along to their new locations. So it's kind of after we finish rendering the lasers that we want to look for the collisions to see if that's happening. Once we've constructed the lasers and moved them a little, then we check to see have they hit anything. So right here we want to detect collisions between lasers and ships appropriately. So I think we're going to need a method for that as well. Now we don't need to pass it the delta time because we're not asking things to move, we're just asking for this method to do what it needs to for the current state. So what will the detect collisions method need to do? I'm going to write a little bit of pseudocode here, some comments about our strategy. So I want to say for each player laser, check whether it, let's say, intersects an enemy ship. And for each enemy laser, check whether it intersects the player ship. So those are the two kinds of checks. And now thankfully we have our lasers in two different linked lists. Let me scroll way up here so that I know which lasers came from where. Not only does that help with which way they move, but also it will help so that I only compare the lasers from the enemy, for example, to see if they hit the player and vice versa. Okay, so for each laser we want to know, does it intersect an enemy ship? Well, to do that, we're going to need to know where is the laser and how big is it, where is the enemy ship and how big is it. So it looks to me like our laser class is going to need a method that will tell us where it is. So right now we have a draw method, and that's kind of all. We can access the X and Y position and the width and the height. So now let's think about how we can pass that information back to the game screen class so it can use it. What if we make a public method that sends back all of that information, those 4 pieces of information? There is a class in the libGDX library called rectangle. So I'm going to return one of those rectangles. Now you'll see there's more than one in the list here. We want the bad logic one. Return a rectangle, public rectangle, and I'm going to say get bounding box. Now a bounding box is, I'll just go back over this picture. A bounding box is this rectangle that goes around the outside, or it bounds. It is the boundary of the image. So that's a common term used. So get bounding box. I'm going to return a new rectangle. And I'll give it the X position, the Y position, the width, and the height. So that's the rectangle that represents this laser in its current location. Okay, we can use that rectangle now with the ship to see, does it overlap. So let's go to the ship class, and we want to write a method here that will check to see, does this ship overlap with the bounding box that's passed into it, which will be the laser bounding box. So public, let's make it a Boolean, because this is yes or no, does it intersect? And let's just do this, intersects. So this is a kind of a question. We'll say something like playership.intersects, and we'll pass in a laser rectangle. So we give it a rectangle. I'm going to call it other rectangle. And we can do something like this. Same idea, rectangle, I'll call it this rectangle, equals new rectangle, passing in X position, Y position, width, and height. And then we can say return the answer to this question. Does this rectangle, and check it out, there's a nice method called overlaps, other rectangle. That's built into the rectangle class in libGDX. Okay, so this will work. If we pass in a laser rectangle, this will tell us whether the rectangle of the laser overlaps with the rectangle of the ship. And because we wrote it in the ship class, both player ship and enemy ship both inherit that method, so they have it already by default. This is not a very efficient way to do this. We're going to improve this shortly, but for now, this is going to be good enough. Let's go back to our game screen. For each player laser, check whether it intersects with an enemy ship. Okay, so our player lasers are stored in, let me just show you again in the structure area here. Our player lasers are stored in the player laser linked list. So we want to look at each one of those lasers and check to see whether it intersects with an enemy ship. We only have one enemy ship right now, so this is just going to be a quick loop. We can use an iterator again. Let's go back and look at our code from that. We can just copy and paste it. List iterator, laser, has next. There we go. Let's grab that portion there. So that was our player laser list. We grab the laser and we want to see, does it intersect with the enemy ship? So if, now we want enemy ship dot intersects with laser dot get bounding box. Oops. So now this is where we will do something if there is an intersection, if that happens. So for now, what I would like to do is just remove the laser from the list of items inside of the list. So the laser will disappear when it hits the ship. So for now, we're just going to say iterator dot remove. You remember from before, that removes the last item that we were working with. Let's copy and paste all of this and do the same thing for the enemy laser list and the player ship. Okay. That will be our detect collisions method. It checks to see what happens if there's any collision. Remove the laser from the list. Let's try it out. Okay, so it looks like when our lasers get close to the other ship, they disappear. So my blue lasers go right up to the edge of the ship right there, and my red lasers, they stop right about there. Now this looks okay with the shields on, but if the shields were gone, let's say the player ship had no shields, we would want that red laser to go all the way into here. So we're not going to solve that problem today because it's kind of a tricky one, but you can understand though that there is a way to solve that problem by paying more attention to the configuration or the shape of this ship here. We are going to work on the shields though, whether the shields should be printed or displayed on the screen or not. Because when the shield gets hit by a laser, we're going to reduce the strength of the shield until it's no longer there. Well, let's look at that right now. So when we wrote the detect collisions method and we simply removed the laser from the list of lasers, that's really not good enough. We want to add in something else, like tell the enemy ship you've been hit. Enemy ship dot, let's say enemy ship dot hit. And I'm actually going to pass it the laser itself because I can imagine in the future there might be different kinds of lasers. Maybe some are more powerful than others, and so how much damage the laser does to the enemy ship's shield might be different depending on the laser. So enemy ship dot hit with this laser, and same thing here. I want player ship dot hit with the laser. We're going to write a method which doesn't return anything, called hit, which takes the laser as the parameter. And for now we're going to write this in the ship class, but we may need to write specialized versions for the player and enemy ships. I think we'll need to do that. For example, the player has lives, but the enemy ship gets destroyed. Maybe we can just, rather than writing an abstract method, we can just override it and call this super method afterwards. So we're going to do this though. If there's some shield left, that is the shield is greater than 0, then we want to reduce the shield by 1. We don't want to keep doing that if there's no shield. We don't want it to go down to -1, -2, and so on. But for now we'll just do that. Later, if we have something more complicated with the lasers, we might use shields as a percentage, something like that. Okay, so that's made a change. Our hit method is now functioning. Let's try it out. Okay, looks like my shields have been destroyed, and you can see more clearly now the red lasers, when they come in, they stop right there. They don't continue all the way to the body of this ship. Let me start that again so you can see it from the beginning. And there goes the shield. Sorry, that starts off screen for you like that. If we want, we can test this by changing the starting amount of shields. So the player starts with 3, let's make it something like 6, and the enemy starts with 1, let's make it 5. Now when we run it, we'll see the shields last a little bit longer. They're getting hit by 2 lasers at a time though, so they don't last for a very long time. Okay, so we've got collision detection happening. We've got the shield disappearing when it's destroyed. That's pretty good. If you're interested in having something more complicated for this collision detection, I might make a second video that shows the more detailed version of how to use polygons to decide whether the lasers are actually intersecting the ship or not. If that's something that you want to know about, maybe post down in the comments below and I'll give you some details on how to do that. It's probably more than I would really want for my students to have to worry about though. So there's one more thing we want to do. We wrote this method intersects here, and every time we test for an intersection, that is for every enemy laser or every player laser, we are constructing a rectangle. Over and over again we're making this rectangle, and it's always the same rectangle for every cycle, for every render cycle in the game screen class. So each time we render and start to check for collisions, it's always the same rectangle. The only time the rectangle changes is here when we update the location of the player and enemy ships. So instead of what we're doing now, creating this rectangle here, I would like to create and maintain that rectangle inside of the update method in the ship class. So we have an update, which for the moment all it does is changes the time since the last shot, but we can also imagine in the future where the position will be moving as well, and so this is where we will update the location information for this rectangle. So let's go up here, actually go to the very top, and we're going to need to make a rectangle to maintain this information. In fact, you might realize we could use a rectangle instead of all of this information here. I'm going to call it a bounding box. And that will be built or constructed down here. Inside the constructor, after we've got the x position, y position, width, and height, I'm going to say this dot bounding box equals new rectangle, and I'm going to give it those values: x position, y position, width, and height. Now, in the intersects method, instead of all of this, I can just check to see, does the bounding box overlap the other rectangle? And now I don't need to create a rectangle every time. We do need to update it though. That happens here inside the update method. So this is where we will replace the old rectangle's information with the current values of the x position, y position, and so on. So let's see how to do that. The bounding box is a rectangle, and it has a method called set, and there are two ways to write it. You can write set to a new rectangle, or you can just change the x position, y position, and so on. So x position, y position, width, and height. It's essentially like saying update to those other values that we already have. So that's a fine way to do it, and now our intersects method will still work, but we aren't repeatedly creating new rectangles every time we do anything. Okay, thanks very much, and I'll talk to you soon. Bye.